Welcome to a presentation on solving linear inequalities in one variable. Let's first talk about what an inequality looks like. We can see here that linear equations and linear inequalities look very similar. However, linear equations have equal signs and linear inequalities have inequality signs. Any value that makes an inequality true is called a solution. When all solutions of an inequality are found, we say that we have solved the inequality. When we go to solve inequalities, we'll find that we have an infinite number of solutions in most cases, whereas when you solve a linear equation, you expect just one solution. So because there's an infinite number of solutions when you're solving a linear inequality, the solutions can be expressed in several ways. You can use inequalities, you can use a graph, or you can use what's called interval notation. So for example, if we have the inequality x is less than 2, any value that's less than 2 would be a solution to this inequality. The graph of that, because of this inequality symbol, we would have an open circle on 2 and an arrow to the left showing any number that we've graphed here would satisfy this equation. This circle is open because 2 is not a solution to this inequality. We should also note that as we move to the left on the number line, we are approaching negative infinity. And I mention that because it's easy now to go from the graph to what's called interval notation. All of these three communicate the same information. If you take a look at the second inequality, x is less than or equal to 3, the less than or equal symbol translates into a closed point because now 3 is included in that solution. If you look at the interval notation to show that 3 is included, we use a square bracket. And these next two examples are similar, except now we have greater than and greater than or equal to. So now our arrow goes to the right, which means we'd be approaching positive infinity, which shows up in our interval notation. Now the good news is, to solve linear inequalities, we solve them just like equations, except if you multiply or divide by a negative when solving for the variable, you must reverse the inequality symbol. Here's kind of an explanation of that. You may want to pause and take a look at this. Essentially what I've shown here is if you add a positive number or subtract a positive number from both sides of an inequality, it's still a true statement. If you multiply by a positive or divide by a positive, the resulting inequality is still true. However, if now we change it and multiply by a negative on both sides, we get a false statement. So in order to make it true, we have to reverse the inequality, meaning the original inequality was less than, but if we multiply by a negative, we have to reverse the direction of the inequality symbol. And the same thing is true if we divide both sides by a negative. We have to remember to reverse the direction of the inequality to maintain the true statement. Okay, let's go ahead and try some of these. We're going to solve these just like they were equations, except remembering if we multiply or divide by a negative, we have to reverse the symbol. So the first step here would be to add 3 to both sides. So we'd have negative 15. Divide by positive 5. So here is our solution stated as an inequality. Let's go ahead and graph this. X is greater than or equal to negative 3. So because of this inequality symbol, it would be a closed point. And because it's greater than or equal to it, we would graph to the right. Again, as we move to the right, we're approaching positive infinity. This would be our graph. If we want to use interval notation, our interval is from negative 3 to positive infinity. It includes negative 3, so we'd use a square bracket. And for infinity, we always use a rounded parenthesis. So that's pretty much it. We've expressed the answer in 3 ways, using inequalities, using a graph, and interval notation. Let's go ahead and try another. So again, we'll solve this like it was an equation, except remembering that one additional rule. So we'll clear our parentheses. Let's get x on one side, so we'll subtract x on both sides. And at the same time, I'll go ahead and get rid of this 8 by subtracting 8 on both sides. So the result of these two steps would be negative 3x that's gone, is greater than, that's gone, negative 28. Now we'll divide by negative 3. However, remember when you divide by a negative, we do have to reverse the inequality symbol. So we're going to have x is less than 28 thirds. For the purpose of graphing this, we may want to rewrite this as x is less than 9 1/3. Okay, let's graph this. Because it reads x is less than 9 1/3, not equal to, we'd have an open circle on 9 1/3. And in this case, our arrow would go to the left because it's less than, approaching negative infinity. So using interval notation, we can see we'd have a negative infinity to 9 1/3, and they're both in 9 1/3, and they'd both have rounded parentheses. We are able to solve linear inequalities graphically as well. So here are the steps we'll take to solve a linear inequality with our graphing calculators. Let's go ahead and apply these steps using this example down here. Step 1, it says we're going to graph the left side as y1. So that'll be our y1. Then we'll graph the right side as y2. And then step 3 will be to interpret the results based upon the given inequality symbol. So the question we want to address here is, when will y1 be less than or equal to y2? So graphically, what the question becomes is, for what x values will y1 be equal to or below y2? And we say below because of the less than symbol. So let's take a look at these graphs and see if we can answer that question. As you can see, I've already typed in y1 and y2. Let's go ahead and analyze our graph. The first thing I recognize is y1 has a positive slope. So this is the y1 and this is the y2. We want to know, when is y1 equal to or below y2? Well, let's first find that point of intersection. If we hit second, trace, option 5, and then enter 3 times, x equals 2 will be part of the solution because we are looking where they're equal. And then from that point, we can see that to the left is when y1 is below y2. So our answer would be when x is less than or equal to 2, since y1 is below y2 to the left of positive 2. I hope you found this video useful, and thank you for watching.